The melting point trend for alkanes is similar to the trend for boiling point. Methane all the way up to decane. I accidentally forgot heptane and decane, but believe me, they follow this trend in this area. From propane all the way through, it does appear as though the melting point increases as molecule size increases, and that's definitely due to the London dispersion forces that are holding the molecules to each other. That's an intermolecular force, and those must be partially overcome in order to melt the solid. Now, what you might notice is that there is a zone here where that is not the case. Now, the boiling point trend for alkanes does not have this anomaly. The melting point trend does. And you have to consider the fact that the crystal structure of a solid actually has long-range organization. It's not just a case of cramming all the molecules together. They've got to form a crystal with some kind of regular repeating pattern. When you have methane molecules themselves are fixed in shape because it's just a carbon atom with 4 hydrogens around it. Those bonds are almost a fixed length, and this molecule itself represents a ball. To create a package of regular repeating ball structures, it's actually pretty easy. You just stack them together so that they're close to each other, and that's that. Ethane is only 2 carbons long, and it has 6 hydrogens total. The only extra degree of freedom that you're allowed here is the length of this bond, but overall it's just a rigid stick. And how easy is it to pack pencils together? Well, you just roll them up into a group and they're stacked. By the time you get to propane, propane has a 3rd axis around which this molecule can bend. That makes it more of a flexible triangle than it does a rigid rod or a ball. And thus, it makes propane tougher to stack in a crystal lattice than methane or ethane. So that actually should convince you that as you are going from liquid to solid, it needs to be even colder to stack a flexible triangle where there's extra work to be done than it is to stack the balls, even though by intermolecular forces, this should have the lower melting point, or rather higher melting point, less negative melting point. Instead, it needs to be just as cold to crystallize propane into its solid than methane, simply because of the extra degrees of freedom and the bendiness of the molecule. I'll draw the hydrogens here for completeness, but long story short, melting is not exactly the same as boiling because you have to consider the crystal structure that you're packing it into. Cool, well that was short and sweet. Best of luck to you.